What you see here is the complete configuration of the PW6001. I'm going to explain to you section by section what this actually means. Now, we have channel 1 to 6, which means 1, 2, 3, 4, 5 and 6. Each channel is a module, and each module has an isolated section of voltage as well as current. This voltage here can take up to 1500 volts AC DC RMS. And similarly, all these are isolated within each other and isolated with ground. This current section here, we do not have a shunt, which constitutes a lot of noise and inaccuracy. We have a system where we could employ a clamp or a CT that will have a zero flux type of sensing, which we will come to that later. The current inputs here are also 6. So the current inputs either can be fed by a Hioki based CT this way, or you can also employ a third party CT by connecting external power supply. For Hioki CTs, the power supply is basically fed from the instrument itself. For external CTs, you also have a separate power supply section that you can connect here. So you have a power supply section as well as the input section. Now, having told you about this voltage inputs and current inputs, so you can shift between these inputs either to use a proprietary Hioki CTs or a third party CT. Then we come over to the motor input section. This employs 4 inputs for motor, wherein you can have torque, RPM, rotary angle and the reference point. Now, you can also employ 2 motors where you have a regenerative motor on electric vehicles. You can have torque and RPM, torque and RPM. So you can employ either 2 motor or single motor. When you employ single motor, you can also have slip because you have this rotary encoder. Now, on the communication side, we have GPIB, RS-232, Ethernet, and we have an optical section which you can isolate this optically, connecting one more power analyzer or similar equipment to extend the channel from 6 to 12 or more. Okay? During which time this can be optically connected to the second equipment, and one will act as a master, the other will act as a slave. Now, this one here is a very important connector here which you see. This is a D2A output, which means a digital to analog output. Here we will be able to, whatever the signal that this equipment captures or analyzes is fed raw through this output. You can connect this to the recorder such as MR8847 or MR6000, wherein you can record these raw 5 megasample signal downscale to even 1 megasample for each channel. The maximum of 16 channels can be recorded, and raw power, raw voltage, raw current, all these raw waveforms can be recorded as waveform data on ASCII and can be later analyzed.